Today we are going to talk about basically graphing, and which is mostly focused on parabolas, which is mostly focused on plotting the equations of the quadratic equation, plotting the graph of the quadratic equation. And quadratic equations are basically parabolas, and so polynomial graphing and parabolas are quite related to each other. And I think lecture one, in the lecture one, I have already talked about that how they're related because a parabola, the equation, the mathematical representation of a parabola is quite similar. It's not just quite similar, I should say it is one kind of polynomial. The mathematical representation of a parabola, the mathematical representation of a parabola is is one of the type or one of a polynomial that is basically also a polynomial. And in our first class, maybe we also discussed what is actually polynomial and what is parabola. So I'm just gonna talk about these things again. So what is the zero of a function? A zero of a function is basically when an equation of the function is provided, you can identify the zeros by solving when f of x is equal to 0. When an equation of the function is provided, you can identify the zeros. You can identify the zeros by solving for when f of x equals to 0. When an equation of function is provided, you can identify the zeros by solving for when f of x equals to 0. It means that if you really want to find the zeros of any kind of function, if you want to find the zeros of any kind of function, then the thing that you really need to do that is you just need to equate the function as equals to 0, and then you need to find the solution. And I hope we all know what is the meaning of finding the solution. And solution solution means that finding the values of any kind of variable, which is the variable of any equation. Do you understand what I'm talking about?
Yes.
Okay, so the root or zero. So the zeros of a function, which is also called the root of a function of the zero of a function is nothing but just solving the equation and equating it with zero and then finding the solution. Do you have any issues with this topic?
No.
Okay, so what are the zeros of the parabola of the equation f of x equals x squared negative 6x plus 5? So what actually this is? We are just asked, we are being asked, we are being asked to find the zeros. And finding the zeros means finding the solution of this equation. I've already told you that finding the zeros of any equation, zeros of a function, is nothing but finding the solution. And finding the solution means you just need to equate it. You just not equate it. You just need to equate it with zero. You just need to equate it with zero, and then you need to find the solution. Do you understand what is the meaning of finding solution?
Yeah.
Yeah.
So
So you just need to equate it, and then you just need to find the solution. And how to solve this equation? We have talked about that in our lecture one, maybe, or lecture two, maybe. That is basically the quadratic formula. You can use the quadratic formula, or you can just use the factorization technique, or you can just use anything you are comfortable with and which is gonna save your time. But the solution will remain the same, which method you are using that really won't hamper the solution. Okay, so we are just trying to find a solution. This is the graph, but they're just using the factorization technique, but you can also use the quadratic formula, whichever you're comfortable with more, and which is gonna take the time less because it's really important, which is gonna take the time less. So how do you plot this equation? How do you plot this uh, graph? How do you set it on the graph paper? How do you want to do that? So there are some procedure. there are some procedure and there are some listed procedure which you can do it. That is basically you just need to I'm they can say in a different way, but I'm just telling you the most the most simple way, okay? The simplest method. I'm just telling you the simplest method. That is basically the first of all things you are doing, you just need to locate the solution. That is the first method. That is the first method. Okay. So
Okay.
what is the solution? What is the solution of this equation? The solution of this equation is x equals 5, and x equals 1. These two numbers are the solution of this given quadratic equation. Okay.
Okay.
So what you need to do, you just need to put the values at x values of 5 and 1, since plugging those two values in to the function will cause the value of f of x to be 0. It means that if you are going to plug the number 5 in this equation, then the function will be equal to 0. And if you want to put the number 1 in this equation again, then you will also get the function is equals to 0. So the thing that you really need to do, that is basically just look at this equation, solve it, and then find the solution, and then you just need to find in which points they're intersecting. Look at the points where the function intersects the x-axis, since the value of f of x or y will be 0 there at points 1, 0 and 5, 0. The function intersects the x-axis. So 5 and 1 are zeros of the function. So I'm telling you again. The second
Yeah.
way you can find the zeros is by examining the graph above. Look at the point where the function intersects the x-axis, because we have already told you in our lecture 1, that is the points in which they are intersecting for any given equation. If you are just plotting the equation of any equation on a graph paper, then the points they're intersecting, the point they are intersecting the x-axis, the point they're intersecting the x-axis, this point and this point, this point and this point. So
Yeah.
these 2 points are basically the solution. And solve, if you have solved this equation, then you would get the solution as x equals
Yeah.
5 and x equals 1. So these two are the solution, x equals 5 and x equals 1. You got me?
Yeah.
So you are 100% sure, you are 100% sure that these parabola is just going to intersect 1, 0 and 5, 0. This
Okay.
parabola is going to
Yeah.
intersect 1, 0 and 5, 0,
Okay.
because this is the solution, and solution means that in which point they are intersecting, in which point the parabola is intersecting, because we are finding the values of x. We're trying to find the values of x, and finding the values of x necessarily mean that what is the value of x, and this is the x-axis, and finding any values of x means that you are gonna find the values of this point and this point, right? Because you are finding the solution.
Okay.
So 1, 0 and 5, 0 are just the coordinate of these 2 points. And then what is the vertex? What is the vertex? And how do you find this vertex? Just guess. How can you find the vertex of this parabola?
Uh, Looking at the middle point.
You can look at the middle point, but I'm just asking you, what is the vertex of this point? Or I mean, what is the coordinate of this point?
-4.
Give me the
3
exact
-4.
coordinate. Exact coordinate.
3 -4.
3, -4. 3, comma, -4. So 3, comma, -4. How do you find, how would you find that number? You
Look
can
at the
think, you can take 1 minute. It's okay, it's completely okay. You can take 1 minute, but you just need to answer me.
where it connects, is it?
I'm sorry, can you please tell me again?
Like where the 2 points connect.
The 2 points are connected, I mean, what?
Like the quadratic equation, they both like have the same number at 3 -4. Is that it?
Uh, I don't think so. Can you please rethink again?
Yeah. What do you mean the vertex, by the way?
The vertex means this is the point, this is the point, this is the vertex, this is the vertex,
Yeah.
this is the vertex. How do you find the coordinate of this point?
I can't remember, sorry.
Uh, just guess. How?
Rise over run?
No. Okay, so I'm just gonna tell you. This is just think about it, and you can just answer me in the later. And this is a kind of your homework basically, and this thing will really
Yeah.
help you. This thing will really help you to think about this problem. My question is, I'm asking you again. This is basically a parabola, and
Yeah.
the solutions mean that the point in which the parabola is intersecting. The
Yeah.
parabola is intersecting the x-axis in this point, at this point, at this point, and the parabola is also intersecting at this point.
Uh-huh.
So, so if I want to sketch the graph of this parabola, then I just need at least 3 points. That would be the most simple way. That would be the simplest way. That would be the simplest way to sketch the graph of this parabola. And to sketch the graph of this parabola, I need 3 points. I need this point. I need this point, and I need this point. And this point
Yeah.
is called the vertex. And I want to find the vertex. And you just need to think how to find the vertex. And next day, you are just going to answer me how to find the vertex of any parabola.
Okay.
Okay, all right. So our next problem is basically our next problem, that is they're asking us what are the zeros of this function. We already know what is the meaning of this zero of the function. What is the zero of this function? You just need to multiply it. You just need to multiply these two products, x plus 3 multiplied by x minus 3, and then you would just get a quadratic equation, and then you just need to solve the quadratic equation. You got me, right?
Yeah.
Okay, then you just need to find the solution, because finding the solution means that finding the zeros. The exact same question here too. And what are the zeros of the function graph below? What are the zeros of the function graph below? Just think and answer me.
Zeros would be
Okay, I'm gonna zoom out. I'm gonna zoom out.
okay. Um 1.25 and -1.25, something like that. It would be a decimal.
Uh,
Oh wait,
what are
no. Sorry. The zeros would be infinity, right?
mm,
Or
they're just asking us what are the zeros of the function graphed below.
0, -2?
0, -3. Okay. So is this parabola intersecting the
Sorry, not negative.
x-axis?
Positive, sorry. No.
No, it's not basically intersecting the x-axis.
Yeah, no.
This parabola is not intersecting the x-axis, because this is our x-axis. This
Yeah.
is our x-axis, and this is our y-axis. And this parabola is just like this, and it is not intersecting the x-axis.
Yeah.
So if it is not intersecting the x-axis, so what is that? What is the meaning? It is not intersecting the x-axis, right? It is not intersecting the x-axis. So are we able to find the zeros?
No, there's no zero.
No, you cannot find any zero. You cannot really find any zero, maybe. So what are the zeros of the function graph below? So since the function does not intersect the x-axis, there are no points at which y will be zero. Therefore, there are no real zeros in the function. Okay. Okay, all right. Okay, all right. So they are just using a term called no real zeros. No real zeros. Okay, they are using a term called no real zeros. It means that
Yeah.
basically this equation have no real solution. This equation, I mean that I have already told you so many times, that is, an equation is a graph and a graph is the equation. You can represent any kind of equation into a graph, and you can just represent any kind of graph into an equation. You got me on? I repeat, I am repeating again.
Yeah.
You can write any equation from a graph. For an example, this is basically a graph, right? This is basically
Yeah.
a car. This is basically a curve, and this is basically a graph. So you can write any equation for this graph.
Yeah.
You can write any mathematical representation. You can do any kind of mathematical representation. A mathematical representation means that you are interested to write the equation. A mathematical representation means that you are interested to write the equation of this graph. This is the mathematical representation. Mathematical representation is just a simple term which you can just use to mean you are interested to find the equation for this graph, because every single equation can be plotted on the graph paper, and they have individual curvature or whatever it is, but you can just plot it. So you can just plot any equation. So it means that vice versa, this graph has also a mathematical representation or a mathematical equation. Am I correct?
Yeah.
So so this equation, the mathematical representation of this graph has a real solution, have and it also has an imaginary solution. And imaginary solution and real solution mean that basically this is basically a situation where this parabola has no real solution.
Yeah.
So this is the case of having imaginary solution. This is the case of having imaginary solution. And imaginary solution looks like this because it is not intersecting the x-axis. In your upper class, maybe in your upper class, whenever you are just studying complex algebra or complex analysis, whatever it is termed, you will understand what is the meaning of imaginary solution, or whatever it is the meaning of the value of I. Have you ever heard of I?
Oh yeah.
I?
Yeah.
Do you know the meaning of I?
Yeah. It's not real. Imaginary.
Okay, so you root over minus one. So you know that, right?
Yeah.
So so this is the case. This is the case because this parabola have no real solution. It means that it is not intersecting. It is not intersecting the x-axis. It is not intersecting the x-axis. So the solution will be consisted of imaginary numbers like this.
Okay.
You understand?
Yes.
Okay, so having no real solution means that this equation will be consisted of imaginary solution, and having the imaginary solution means that the solution will be consisted of the imaginary number, the imaginary unit, iota. This is called iota, okay?
Okay.
I-O-T-A, iota. I equals root over minus 1. Root
Yeah.
over minus 1. Okay?
Okay.
Okay, all right. So this is basically the case. So what are the zeros of f of x equals You just need to also multiply. You just need to, but okay, so you really don't need to find the zeros. Okay. I, I just want to tell you a trick that is basically, I am really interested to tell you the trick that is, you really don't need to multiply. You really don't need to multiply. You really don't need to multiply x plus 3 multiplied by x negative 3. You don't need to do that. You really don't need to do that. The thing that you really need to do that is basically you just need to equate it with 0, and then you just need to equate it with 0. You got me or not?
How do you do that?
Okay. It means that x plus 3 in multiplied by x minus 3 equals 0. It means that okay, x plus 3, x minus 3, x plus 3 and x minus 5, right?
Yeah.
X minus 5. Make this equals to 0, and you also make this as equals to 0, which means that x plus 3, actually I'm using my mouse, x equals negative 3, right?
Yeah.
Because you are just equating. You
Oh
are just
yeah.
equating this product
Oh
as 0. And you are also interested to equating this product as 0. X minus 5 equals 0. X minus 5 equals 0. So x equals plus 5, right?
yeah.
So it means that if they're trying to tell you the quadratic equation in the product form, this is not the standard form. This is basically the standard form. This is called the standard form. So you don't need to multiply it. The only thing that you need to do, that is basically you just need to equate it with 0, this term separately and this term also separately. You got it?
Yeah.
Okay. X equals negative 3 and x equals positive 5. These two are the solution of this quadratic equation. And the solution means that the zeros of the function. So this is it. This is it. So what are the zeros? The same procedure. The same procedure. You also need to apply. You also need to go through the same procedure that I have just talked recently. The very last technique. Equate it with 0. This x equated with 0. X equals 0. X minus 1 equals to 0. X plus 2 equals to 0. And x minus 9 equals to 0. X minus 9 equals to 0. The same procedure. The same exact procedure. You just need to equate every single term, every single product of this polynomial or this equation with 0. You just need to equate every single term with 0. What is the meaning? Basically, for an example, what is the meaning? What is the meaning? How and why are we doing it? Just consider A multiplied by B multiplied by C multiplied by D equals to 0, right? So
Yeah.
can you hear me?
Yes. Okay.
Okay. So if I'm asked to find the values of A, B, C, and D, then how do you want to find it? How do you want to find it? The only logic here, and the only correct logic here is, it is only possible in that situation. It is only possible in that case when all of these variables are equals to 0, because there is no such real, there are no such real number,
Yeah.
with which you will multiply by 0 and you won't find a 0. There are no real number with which you are multiplying by 0 and you are not getting 0. It means that the only situation, this left side will be equals to 0. This left side will be equals to 0. The only case that is any of this, maybe any of this, maybe any of this, A, B, C, or D, A or B or C or D is equals to 0.
Yeah.
Because consider A equals 5, B equals 10, C equals 20, and D equals 0. So whatever it is, A multiplied by B multiplied by C, D is equals to 0. As D is equals to 0, and you are just multiplying this whole number with a 0, and you're just getting a 0, right?
Yeah.
So the logic is any of them is equal to 0. Any of them is equal to 0. So the procedure of solving this equation is you just need to give the space that A equals 0 or A equals 0 or B equals 0 or C equals 0 or D equals 0 and so on. Okay. So A equals 0 or B equals 0 or C equals 0 or D equals 0. So you just need to apply the same technique here. You just need to apply the same technique here. Here, the A is represented by X, the B is represented by X minus 1, the C is represented by X plus 2, and the D is represented by X minus 9. So you just need to equate. You just need to equate individually. You just need to equate individually the terms with 0. X equals 0, X minus 1 equals 0, or X plus 2 equals 0, or X minus 9 equals 0. You got me or not?
Yeah. So I have a question.
Okay, sure, please.
On that last equation, the example one,
Okay,
yeah, that one, number
yeah.
4.
Okay. Are you just talking about this problem?
Yeah, this one, number 4.
This one number, uh, I'm sorry, can you please tell it again?
This one. This one.
Are you just talking about this problem?
Yeah, so the x before the x minus 1, is it just 1?
X minus 1, you're just
No,
asking what is
before
the
that.
value?
No, the x, yeah, that the x outside of the parentheses.
You just need to consider the No, you just don't need to get rid of the parenthesis. Just just like you just need to keep it like this. But you are just if you are
You
just
just
gonna
use this things
okay. So
like
if you
like
want to
the
sorry,
sorry.
please ask the question. Your question is basically you just keep the parenthesis, right? You are thinking what about the parenthesis, right? You are
No,
just
no, no.
asking
No, the x before the parentheses, is it just 1?
x before the parenthesis. X before the parenthesis.
Yeah, that one doesn't have any like value.
Okay, so you're just asking these x before the one. It have a number 1, right?
Yeah.
Okay, so you're just telling me that just like 1 x into x minus something, right? Like this, right?
Yeah, yeah, is it like that?
Okay, but maybe, and the simple answer is basically the simple answer is the simplest answer, that is, write this one as 1, and then use the curly braces, and then use just like this x minus something dot 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 dot, dot whatever the products
Okay.
are equals to
Okay.
0. So you are not allowed to write 1 equals 0. You are not allowed to write 1 equals 0. You cannot write, okay? You cannot write 1 equals to 0. You cannot write that 1 is not equals to
Yeah.
0. Then you just need to okay, these two are also product, right? Am I getting your question? Am I getting your question?
No, yes, I know what you mean.
So
I was, yeah,
you just asked me that the x before the parenthesis also have a 1. So there is a hidden one, right?
Yeah.
There is a hidden one. Okay. So the thing is, this is basically a one, but we have these this whole term, this whole expression. Write this one as one, and then close them with a curly braces.
Okay.
Close them with a curly braces, and then the thing will remain like this, right?
Yeah.
The
So
same
it doesn't
procedure.
matter.
Now that it's the same procedure. Now it look like the same procedure because A, B, C, and D.
Yeah.
Okay, all right. So consider it A, B into C into D into E.
Okay.
Consider that this A equals 1, right? This A
So
equals 1.
the one just doesn't matter, right?
No, definitely not at all. Not at all. Not at all. You cannot
Okay.
just write 1 equals 0. You cannot
Yeah.
write 1 equals 0. You cannot write 1 equals 0.
Yeah.
Because just like consider this case, because maybe this A has the value of 5 and this B has the value of 7 and this C has the value of 0 and this D has the value of 8. Just consider like this, okay? Just consider like this. And for an example, you are just writing A is equals 0 or B equals 0 or or C equals 0 or D equals 0. So this is basically the concept. So the thing is you are not writing 1 equals 0. You are not allowed to write 1 equals 0 because we really have the numerical value here. We really have the numerical value here. But whenever they are connected with some variables, multiplied by some variables, then you can just equate these variables. You can just equate the variables with zero individually. You can equate the variable term, you can just equate individually the variable term with zero. You cannot write one equals zero because that's not the solution. But these two product of this and this are equal 5 x equals 0. So how do you find the value of x? The, the the only procedure is basically considering x equal 0 by 5, and just for an example, if you really want to take this 5, if you want to take this 5 from this left side of this equation to the right side of this equation, then you just need to do the division, right? That's the basic rule of equation. That is one
Yeah.
of the basic rule of equation, and that is why I'm doing it. Some people write like this. They write like this: 5 is divided by 5 is equals to 0 divided by 5. But this is very time consuming. This is very time consuming because this 5 and this 5 is cancelled, and then x becomes to 0 by 5 equals 0. Okay, so what is the solution? 6x. What is the solution of 6x? So just like the previous, equation, if you want to take the 6 from the left side to the right side of this equation, want to take this 6 from the left side of this equation to the right side of this equation, then you just need to divide. And after that, xy equals 0. So, so x equals to 0 or y is equals to 0. X equals to 0 and y equals to 0. Okay, but just think about it. Just think about it. You're just writing these. You're just writing. You're just writing. You're just writing this line, this expression from this line, from this line. You're just writing this expression from this line, right? So
Yeah.
6xy equals to 0 doesn't doesn't really that much value, doesn't potentially hold any kind of value, writing it xy equals 0. Or writing xy equals 0, writing xy equals 0 mean the same as writing 6xy equals 0. 6xy equals 0 because it doesn't it doesn't really have any meaning having this 6 as a coefficient of this xy. You cannot just write 6 equals 6 is you cannot just write, for an example, 6 equals to 0 or x equals to 0. No, that's not the way. That's not the way. And you cannot just write it because if you just want to consider it, not in this procedure, if you really don't want to consider this problem solving procedure, then you just need to consider it as
Yeah.
the 6 is a product and the xy is also a product. The xy is
Yeah.
also a product. Divide and rule. Divide and rule. Okay. So
Yeah.
6 cannot be equals to 0. So it means that 6 cannot be equals to 0. So it means that the only way that this equation can be 0 is xo equals to 0. Because 6 cannot be equal to 0. So now divide and rule. Divide and rule. Like, so x equals to 0 or y equals to 0. You got me or not?
Yes. Do they both have to equal or just one?
No, they both have the equal. They both. I mean, are you asking about this 6 is equal to 0 or not, or this
No,
xy is equal
like
to?
what you wrote just now, like x is equal to 0 or y is equal to 0. Do they
They
both
can.
have to or just either?
No, they can. This is
Oh,
basically a
they.
possibility. This is basically a possibility. Because I am
Oh, okay.
writing or because I'm writing
Yeah.
or because I'm
Yeah.
writing x equals to 0 or y equals to 0, because maybe they both are 0, or maybe one of them is equals to 0. Maybe they both are 0, or maybe one of them is just equal to 0. You got me
Yeah.
or not?
Yeah.
They both can be 0. It's very possible. It's a possibility. There is a high possibility that it's just like a 50-50 chance that they both are equals to 0, and any of them is equals to 0. You got me?
Yeah.
Okay. Just consider this equation. 14wxy is equals to 0. This is basically uh, method number 1 to solve this problem. This is method number 1. 14wxy equals to 0. Taking this 14 to the right side of this equation will give you equals to 0. Okay. Then, then equate this equation with 0, w equals to 0, or x equals to 0, or y equals to 0, or z equals to 0. This is procedure number 1. What is the procedure number 2? The procedure number 2 is consider this 14 as a product, and w, x, y, z is also a product. These two products, this cannot be 0. This cannot be 0. This cannot be
Yeah.
0. So
Yeah.
definitely it is 0. So definitely it is 0. This term is 0. Actually, I cannot call this as a term, but I'm just telling you for your conveniences to understand. But this is not not a term. The definition of a term is not like this. This is basically not a term. I should call this a product. I'm just telling you for your convenience. Just consider it as a term. So this term is equals to 0 because 14 cannot be equals to 0. 14
Yeah.
cannot be equals to 0. So w x y z equals to 0. So w x y z equals to 0. What is now? Break it again. Break it again. Break it again. W equals to 0, or x equals to 0, or y equals to 0, or z equals to 0. Z equals to 0. These four possibilities. There are four possibilities. Maybe w equals to 0, or x equals to 0, or z equals to 0, or y equals to 0. Or maybe they all are 0, but we are not interested in that situation. We are not interested in that situation where everyone is 0. We are just trying to tell you that w equals to 0, or x is equals to 0, or z equals to 0, or y equals to 0. You cannot write 14 is equals to 0.
Yeah.
That's not the solution, or that is not logic, because that is not a logic, because I have told you the fundamental rule is when the multiplication, the product of multiple variables, maybe they have some coefficients, is equal to 0, just like this 14wxyz equals 0, 14wxyz equals to 0. Maybe one of them or all of them, maybe one of them or all of them of the variables are 0. Maybe one of them of or all of them are equals to 0. I'm not talking about this coefficient. I'm not telling this coefficient is also 0. You got me?
Yeah.
Okay. Okay. All right. So now we are interested to parabola graphing. Basically, we are highly interested in graphing the parabola. So in this situation, in these mathematical problems, we are we are we are being asked to graph the equation to graph the equation of parabola. And a parabola basically they have so many different type of equations. Different type of equation means the as we talked about in the straight line, as we already talked about in the straight line, the straight line has some different forms of the uh, equation because the straight line can possess the formation of the equation, the formation of the expression of the equation, formation of the expression of a straight line can have different forms. For an example, we can write as y equals mx plus b or mx plus b. We can also write ax plus by plus c is equals to 0, and we can also write x by a plus y by b. I'm sorry for my bad handwriting, I'm extremely sorry for that. X by a plus y by b equals to 0. We can also write like this, and we can also write some different type of forms, and this is a form, this is also a form, and this is also a form. This y equals mx plus b, x plus by plus c equals 0, and x by a plus y by b equals 0. These all are the forms of the straight line, the forms of the expression or the equation of a straight line. These all are the equation of a straight line, all of the equation of the straight line, but they have some different image, they have some different faces. They look different, the equation look different, but they all are the equation of the same type of graph. For an example, having uh, maybe they are just like twins, but um, they have some differences. For an example, I'm just giving you some examples, just trying to letting understand what is basically the meaning of having different equations, different forms of equation of a parabola. Because in your just previous class, in your previous class, I have told you that this is basically an equation of a parabola: ax squared plus bx plus c. This is basically an
Yeah.
equation. This is basically an equation of the parabola. So a parabola, just like the straight line, just like the straight line, can also have different forms of equation, different forms of equation. You can represent a parabola. You can represent a parabola by using different forms of equation, different forms of mathematical expression. So uh, each form, each form of the equation of a parabola has different advantages and disadvantages. We are not interested to find out the advantages and disadvantages of any kind of equation, any kind of form of equation, but they give some intrinsic help. Basically, they all have some pros and cons. They all have some pros
Yeah.
and cons, and they sometimes help us to do a particular thing for a particular reason. What that basically mean? What that basically mean? Okay, so consider. I'm gonna talk about this later, but the thing that I'm gonna talk, they are also telling the same. So I am not interested in this kind of thing. Let me tell you from my point of view. So this is basically an equation of a parabola. This is basically an equation of the parabola. So in your previous class, I just recently, this is also an equation of the parabola. So what is
Yeah.
the difference of this equation? These two different type of equations. Can't we just write just like y equals x squared plus bx plus c? Definitely we can write that. Definitely we can write that. But these formation, these formation, these formation, this given formation has some advantage. has some advantages. Has some advantages. So just like the different forms of straight line, different forms of equations of a straight line, we also have some advantages and disadvantages for each and every single form of the straight line equation. Because if you know the value of m, if you know the slope, if you know the slope and the y-intercept, then you can just plot the graph of this type of equation. That's simple. But in this case of the in this case, you if you want to plot the if you want to plot the graph of the straight line, the only thing that you need to know, that is basically you just need to know the unit the unit of the unit of the x-axis, the straight line is cutting or intercepting, and the y units, the straight line is intersecting or intercepting, just like this. This is gonna be the a value, and this is gonna be the b value. This is gonna be the this is going sorry, I'm sorry. Uh, this is gonna be the a value, and this is gonna be the b value. So what I mean, I am trying to mean that each and every single different form of equation for a given type of graph, whatever it is, just consider as a straight line or a parabola or an ellipse or an hyperbola, they have some advantages and they have some disadvantages, and all of the forms have different meaning. Different meanings mean they have some pros and cons. So the equation, this equation of a parabola, this equation of this parabola has some advantages and disadvantages. Has some disadvantages and advantages. So how do you want to do that? Because we're just asked this, what is the vertex of the parabola with the equation? Because we are interested to find the vertex. Because
Yeah.
we are really interested to graph a parabola. So to graph a parabola, to plot the graph of a parabola or a parabolic equation, you need to know at least 3 points. You need to know at least 3 points. In some cases, actually, the thing is, you just need to practice. And if you really want to practice, then you will understand what I'm talking about basically, because you can um, you can plot the equation. You can plot the equation of any kind of parabola just by knowing the solution. If it's a real condition, what is the meaning of real condition? I will talk about that later. But but just try to understand, that is, mm, consider it like this. Consider like this. For an example, um, this is a parabola. To
Yeah.
plot, for an example, we have just, because if we want to know, the graph, if we want to know the graph of this parabola, then at least we need to know 3 points. This point, this point, and this point. You need 3 points. But if you really don't want to know the 3 points, then at least you just need 2 points. That is basically the solution. This point and this point, and you can just automatically guess this point. So practically or technically, at least you just need to know practically, or maybe intuitively, you need to know at least 2 points. That is basically the intersection point of the x-axis or
Yeah.
the zeros of this parabola. Because if you know this point and this point, then this, the distance between these 2 points, the average distance of these 2 points, the middle point would be the vertex of this parabola. This is called the vertex. This is called the
Yeah.
vertex. So technically, actually, you just need to know at least 3 points. You need to know 3 points, but at least, you need to know 2 points. And in the meantime, technically and intuitively, you will be automatically be able to find out the third point, which is basically the vertex. And there are also mathematical procedures to find the vertex. But if you really want to sketch the graph of a parabola, then you can just sketch it in like this way. You just need to plot the solution or the zeros, and then find the average distance between this point and this point, and then you can just assume it as the vertex. We have mathematical ways, we have mathematical procedures to find the vertex. For an example, how do you find the vertex? You can use this formula, x equals minus b by a. But to use this equation, x equals negative b by 2a, x equals negative b by 2a, you just need to convert any form of equation, any form of parabolic equation into like this, okay? You just need to convert
Yeah.
any kind of equation into like this. For an example, in this case, in this case, you don't have the formation. You don't have the formation of the parabolic equation, the equation of the parabola like this: y equals x squared plus bx plus c. You got me?
Yes.
Do you understand what I'm talking about?
Yes. Yes.
So you need to convert these formation of equation into this.
Yeah.
You need to convert this equation, the formation of this equation, into this. This is simple multiplication, addition, subtraction, and exponential. This is nothing but uh, do this a minus b whole square, then multiply it by 3 and do the subtraction. You would get these expression like this. This is simple as drinking water. And then after you have just converted with the standard equation, this is called the standard equation of the parabola. If you read some mathematics text, then you would understand what I'm talking about basically. So y equals x squared plus bx plus c is the standard equation of the parabola. So if you convert it in this form, then just find x equals negative b by 2. This is the vertex. This is the vertex. This is the vertex. So this is a mathematical procedure. This is a mathematical method. But this form of parabolic equation has some value, has some advantages, What is the advantage? What are the advantages? The advantages are the advantages are they are just trying to hide. They're just trying to hide uh, the information of the vertex like this way, because we already have the hidden information to find out the vertex of this parabola. We have the hidden information. How do you describe that information? Notice that the equation is already in vertex form, and we are calling this formation of the parabolic equation is the vertex form, because I am calling this as the standard form. Y equals x squared plus bx plus c. Bx plus c is the standard form of the parabolic equation, and I'm calling this form y equals a x minus h whole squared plus k is the vertex form. So the vertex form has the advantage, or the vertex form will provide you the advantage to find out the vertex very easily. And how do you do that? How do you do that? How do you do that? The vertex of the parabola is negative h comma k. Negative h comma
Oh,
k. So the vertex is the vertex is 4, negative 7. 4, negative 7. This is the vertex.
okay. Yeah.
H comma k. H comma k. This is the vertex. And if you study circle, if we really have the scope to discuss about circle in terms of coordinate geometry, then you would understand what is the meaning of H and K, because um, actually you can just this is basically a standard form, and H comma K you would also find this H and K in circle, in ellipse, in hyperbola too. And you can just automatically find the center or the vertex or whatever it is by just looking at the equation. Just looking at the equation. So y equals a x minus h whole square plus k. So x minus h whole square plus k. So I told you that the vertex is h comma k, right? So the h correspond 4 is the corresponding value of h, and -7 is the corresponding value of k. How the 4 is coming? Because we can see that the 4 has the negative sign. Then how it is how the positive 4 is becoming h? Can you please tell me that?
How the H is, sorry, what?
I'm just telling you. I'm just asking
Yeah,
you. I'm just asking you that this x minus 4, this
yeah,
x minus 4 whole squared, you can see the 4 has the negative sign, right? The
yeah,
4 has the negative sign.
but
Then,
it's positive 4.
so why the h is having this positive 4? Why the value of h is becoming positive 4? Why?
Because on the equation, the formula, it's the opposite sign. So it would be, like, if it's a negative, it would be a positive.
Okay, yeah. So for an example, if I have like this, y equals a, I'm sorry, I'm writing it again, y equals 3 x plus 4, x plus 4 whole squared minus 7, then what would be the value of h and k? What would be the value of h and k?
Be H would be -4 and K would be -7
Why?
because
Why?
the H is opposite and the K stays the same.
Okay, but do you understand that we just want to write the equation in this form, like x minus k, the x minus k form? Do you understand that? What that means? What does that mean? That is basically you just need to keep the negative sign before the x. So if you
Oh,
really
in the
want to,
equation? Yeah.
you have given me the right answer. You have told me the right answer, but I'm just
Okay.
telling you for your clarification that is you just need to write this equation. You just need to organize you just need to manipulate the terms like y equals 3 x. I'm sorry for my bad handwriting. X omg. I'm sorry. X minus minus 4 x minus
Oh
minus
yeah.
4.
Oh yeah. Yeah.
This curly braces. I'm extremely sorry for my handwriting.
No worries.
OMG. -7. Do you got it?
Yeah.
Because these negative sign and this negative sign will give you the
It
positive sign.
cancels. Yeah.
So these -4 has the value of 8. Am I correct or am I wrong?
Yeah. Yeah. Correct.
So you got it right.
Yeah. I
You
noticed.
just need to practice and you just need to make some notes. Maybe um, it's a tough time. Basically, we really don't have that much time, but these things are quite critical, and you really need to go through. Because if you really don't want to go through, then you really cannot make it through because um, quite sensitive. Because uh, you just need to make the given equation look in the same exact way. Here I can just tell that h is equals 4 and k is equals to -7. But if this plus minus is just alternate, then the situation will be complicated for you if you are not practicing. In that case, only in that case, if you are not practicing, because you really need to go through and make some notes. And the only way to do better is you just need to go through some standard mathematics thing. Because That text won't teach you any kind of mathematics. And I wish I had the notes written in English anyway. So what is the vertex of the parabola with the equation y equals 4x squared minus 2x minus 3? How do you do that? Apply this equation because we have already given in the standard form, right? This is basically
Yeah.
the standard form of the parabola. Standard form of the equation of parabola, standard equation form. So the simplest way to do that is equals to x equals negative b by a. So I asked
Okay.
you how
Yeah. Can I say, wait, what would be the vertex of this
the
curve?
vertex would be x equals negative b by a.
Okay. Um,
The
can
vertex
I
would be x. Sorry,
can
sorry.
I solve, can I solve it and then ask you if it's right?
Can you please tell me again?
Yeah. Can I solve that first? 1 second. I just
Yes,
want to
you
try
can.
it out.
Yeah, sure. You can do that. You can do that.
Is it negative 2 over 2 times 4?
Negative 2, negative 2
Or,
divided by negative 2 divided by 2 into 4. That is negative 2 divided by 8. And we have a positive number that is 2 divided by 8. 1 by 1 by 4. Maybe 1 by 4 is the answer. Positive 1 by 4 is the answer. Maybe positive 1 by 4 is the answer. Have you got the solution?
yeah, that's what I.
Always you just need to make them look similar. You just need to make them look similar. If you want to practice, if you don't practice them, you won't understand what I'm talking about basically. Because what is the meaning of making them look similar? What is the meaning of making them look similar? Because you cannot just write that b equals plus 2. You cannot just write because here in this equation b is not equal to plus 2. No, no, that's wrong. Y equals ax square plus bx plus c. So in this equation, y equals plus 4, just for your convenience, plus 4 x square plus this negative 2 x plus negative 3. Do you understand right now?
Yeah,
This is the
yeah,
value of a, this is the value of b, and this is the value of c. This is how you
yeah.
need to compare. This is how you really need to compare. This is the only way to compare.
Okay,
Please don't mess up with the signs. Don't mess up with the sign because the plus minus will really give you some trouble at this in this case. Y equals a into x minus x whole square plus k. If it is plus 4, I have already told you, then you just need to use some curly braces, maybe. Or if you are able to do the calculation inside your head, then it's completely okay. But at least if you really cannot process inside your head, then write. Then use pen and paper, okay? Then use pen and paper. That will really help you to not mess up with the signs. Because is the H positive or negative? If you just mess up with that sign, then the whole solution will be wrong. The whole solution will be wrong. Okay. So identify the x value halfway between the zeros. This is what I just told you. The very first stage. The very first stage. I think this is the simplest way to find out the vertex. We know the solution. We know the solution. What is the solution? The solution is the the point in which the parabola is intersecting the x-axis. This is a point, and this is also a point. And the vertex would be the middle point, the halfway between these 2 points, the halfway is like this. The halfway is this point. The halfway is this point. So you can just sketch like this. You can just sketch like this, but this won't give you a exact good solution, because you really don't know the exact vertex coordinate for this parabola. The best way to find out the vertex of any kind of parabola is using this formula, x equals negative b by a. And first of all, you just need to convert the given equation look like this standard form, or if it is given in this vertex form, then automatically you can just compare with the values of 8 and k, and you can tell the vertex. And this formula is basically came from the calculus, which is basically finding the maxima and the minima. This formula has basically came from the maxima and minima. If you ever read calculus, then you would understand what I'm talking about. Basically, finding the value of maxima and minima give you this formula, because this is basically the maxima. This is basically the maxima of these equations. You don't need to understand what is maxima and what is minima. In your upper class, you will understand what is maxima and what is minima. This is basically, you can just find it by using the concept of calculus. The concept of calculus, you can just find it by using the concept of calculus. Negative b by 2a, negative b by 2a. Okay. So I hope you will understand this thing. And what is the vertex of the parabola with the graph given below? Simple, 0, 0. Am I correct?
Yes.
0, 0. 0,
Yeah.
0. You just need to practice. That's the parabola. That's the parabola 3x minus 2 whole square plus 9 open upwards and downwards. What is the vertex of the parabola with the equation y equals 4x minus 1 whole square plus x? What is the x coordinate of the vertex of the parabola with the equation y equals x plus 4, x minus 8? These all problems are for your homework. I'm not going to solve it here because you just need to think. Because these problems, if I am going to solve this thing, then you won't be able to think about this problem, because these are some amazing problems. These are some amazing problem, and if you really want to work out this problem, then your thinking capabilities will enrich. There's the solution, but you should at least try for your own side. And I'm going to talk about this later. If you really don't understand, then I'm going to give you the solution, but at least you just need to go through the problems. Please, at least go through the problems. Okay, so um, we have some visualizing problems and then polynomial visualizing. Okay, so in this case, actually, we're just going to talk about some function transformation. What is the meaning of function transformation? Function transformation means that we have given a function, and then you just need to give it a different form. A different form. Giving a different form doesn't necessarily change the function itself. Just it is just some algebraic manipulation, just some basic algebraic manipulation, and which gives you a different look of the algebra, a different look of the algebraic equation, but it doesn't change. It doesn't change the function itself. It doesn't change the function itself. So, so what that test is telling us, the book or whatever it is, they are just telling us it is useful on some stat math problems to know how changes to a function's equation can impact its graph. It is useful on some stat math problems to know how changes to a function's equation can impact its graph. Here are some key relationships to know. Suppose we have the function y equals x squared. Can you tell me what is basically this equation is? What is the card name? What is the name of this card? What this equation is representing?
Square root or
Sorry?
square? Square?
Okay, it's a
X.
square, but I'm asking you to tell the name, to tell the name of the card, to tell the name of the card or the graph. The graph of what is the graph called for the y equals x square? If you graph it, if you plot it on a graph paper, if you plot it on a graph paper, then how this graph will look like? We have different names for different cards, right?
Yeah.
So what is the name of this card? Y equals x square. The name of the card or the name of the graph. Or if you just plot this equation on a graph paper, you would get a graph. What is the name of this graph?
Is it parabola?
Exactly. Exactly. It is parabola. Exactly. It is parabola. This is the parabola looks like.
Mm-hmm.
So we are just interested to find the function manipulation or the function transformation. The function transformation mean that function transformation mean that you just need to you just need to make some changes in the function, or maybe actually the changes that you need to make, that is basically on the equation, maybe some equations, some parabola or some geometrical equations, and then you just need to tell what would happen. What would happen? There are so many rules. There are so many rules on the function transformation. If you add, if you subtract, if you multiply, or if you divide uh, a function, a term with some other terms, then different things will occur. Different things will occur. But we are not interested in all the situations, in all the possible cases, rather than we are just trying to focus. That is basically that type of problem which can appear on our SAT test. So this is basically our main goal. Because if you this is a function, so you can divide it, you can subtract it, you can do so many things on it. You can just do any kind of operation. Just consider it, as a as just you can just do any kind of operation. And if you want to do any kind of operation, I mean, if you want to multiply this equation, if you want to multiply the right side of this equation, then you also need to multiply with the same number or the same term of the left side of this equation. You can do whatever you want. But the thing that basically you need to focus, that is, you just need to assume, or you just need to predict, or you just need to guess what thing can happen, but doing what thing. What thing will happen by doing what? What thing will happen by doing what? What thing will happen by doing what? And we are not gonna discuss, we're not gonna talk about in every possible cases, in every single situation, what is gonna happen by doing what. We're not gonna deal all the possible cases, because there are so many situations, so many possible cases that you can just look at, and you can just guess what thing is gonna happen doing what. So we're not gonna interested in all situations, then the then the syllabus will get too much large. So rather than this textbook is suggesting us to focus on some particular situation, or some particular cases, that we really need to focus on. We need to focus on, and we just need to predict. We just need to predict what things are going to happen by doing what. Okay, so the rule number one is telling us, for your kind information, treat h and k as constant for this rule. So rule number one is telling us, if you transform f of x to f of x plus k, the function will shift up k units. So this means that, for an example, you have been given this equation, and you just want to know by doing what operation that will result an upshifting in the function. For an example, you are just given this equation, and you are asked to determine, or you are asked to predict what thing will happen, or what thing can we do to shift up this graph, to shift up k units in this graph. What thing? The answer is the answer is to shift up of the graph of this function. We need to add the amount of units we are interested to shift it up onward. You will come more familiar. You will come to know about more of this situation if you solve some problems. If you solve some problems, I will talk about that later. But just consider this example. Um, just consider this example. They're just trying to tell you that if you add 2 units upward shifting, 2 unit upward shifting with this graph of y equals x squared plus 2, y equals x squared plus 2. If you add 2 units upward with the graph of y equals x squared, then the graph will look like this. This is basically the equation. This is basically the graph, the plot of the equation y equals x squared, and we have shifted up onwards. We have shifted up onwards by 2 units. You got it?
Yeah.
Okay. Because there are so many situations. Because we are interested what thing will happen by doing what. There are so many things that we can do, and we can just ask what will happen, adding this, what will happen subtracting this, what will happen multiplying this, what will happen dividing by that, what will happen by taking the exponent into this, taking the exponent into that. But we are not going to talk about so many situations because SAT is not suggesting us to know all of the situations. Rather than focus on some particular situation that are being suggested by this textbook. Okay, so now come to the rule 2, which is telling us if you transform f of x to f of x minus k, the function will shift down k units. If you transform f of x to f of x minus k, the function will shift down k units. So it means that just consider an equation that is y equals x squared. Consider an equation that is y equals x squared. And if you want to shift it down, the equation y equals x squared, just don't think about this -2. Just don't think about -2. Just primarily consider the equation y equals x squared. Y equals x squared is an equation. So if you want to shift it down, shift the graph of this equation, y equals x squared downwards, in the downward direction, in the down direction, in the below direction, then what thing do you need to do? You need to subtract. The amount of units that you are interested to take it downward. You just need to subtract the amount of units you are interested to take in the downward. So what that will look like, the thing that will look like, that is basically, this is the basic equation of y equals x squared, and we have just shifted it down. By 2 units by subtracting it with -2. You got it?
Yeah.
You just need to practice. You just need to write down some rules, because you just need to make some good notes. You just need to make some extremely good notes that is feasible with your own mindset. And then you need to practice. And you can use different tools making notes. You can use different software, digital notes. You can use Microsoft OneNote. You can use GoodNote. You can use Notion. You can use Evernote. You can use Apple Note. Whatever it is, you just need to make notes, because if you don't make notes, you at some moment you will fall. And if you don't know how to rephrase, then you just cannot do the retrieve of your knowledge, because there are so many things here, and we just need to cover them all. We just need to cover them all, and we just need to at least we just need to take some things inside our memory. And to do that, we just need to make notes. We just need to write down the rules, and we just need to write down some problems, some examples, and the solution of that example. That's the way of making notes. Because if you don't make notes, then you won't be able to remember or recall all of these problems. Anyway, the rule number three is telling you, the rule number three is telling you, if you transform f of x to f of x plus 8, the function will shift left h unit. Because we have already told you, uh, how to shift it up in the upward direction and how to shift it down in the downward direction. How to shift it up in the upward direction and how to shift it down in the downward direction. I've already told you that. And now we are interested to tell you how to shift it left direction and how to shift it in the right direction. You got it?
Yeah.
Okay. So we are just interested in this case how to shift it left, how to shift it left direction. If you transform f of x to f of x plus h, the function will shift left h units. The thing that is going to happen here, that is that the function, the graph will shift left direction, the left direction. What does that mean? What does that mean? This is the case where the graph, this is the case where the graph is shifted in the leftward direction. It is shifted in the leftward direction. This is the leftward direction. This is the ideal situation. The ideal situation will look like this. The ideal situation will look like this. This is the ideal situation.
Yeah.
This is the ideal situation. And the ideal situation is becoming the non-ideal situation. Non-ideal situation when you are just shifting it in the left direction. When you are just shifting it in the left direction. And to do that, what thing do you need to do? What thing you need to do what thing you need to do what? You need to add a constant term. You need to add a constant term. You need to add a constant term with the x. Then the graph of the function will left in the left direction with h unit. You got it?
Mm. Yes.
This was the ideal situation. The ideal situation was like this. This was the ideal situation. You got
Yeah.
it?
Yeah.
It is being shifted in the left two direction. Consider this one and consider this one. These two vertex, these two units. Okay?
Mm.
All right. Now, for your kind information, the ideal situation is just for this graph. For this graph is this is the vertex. This is the vertex. So the
Yeah.
ideal situation is like this, like this. Okay.
Yeah.
So you're just shifting it downward direction, in the downward direction. This is in the downward direction. This was the ideal thing. This was the
Yeah.
ideal thing. What is the ideal case? The ideal case is just a case which we are taking as a frame of reference. The ideal case is the case which we are taking as a frame of reference. We are just taking it as a reference. There is no exact ideal or exact pure situation. We just need to compare. And to compare, we just need to have a benchmark. We just need to have a reference. And the reference is being called as an ideal situation. Because if you really don't want to consider the ideal situation, then you cannot just compare. And to compare, you definitely need an ideal situation, because having no ideal situation, you cannot compare. As the same, if you're not transform in the right direction, then you just need to subtract. You just need to subtract. You will understand while you are solving some problems. Okay. It will be reflection. This is called the reflection. If you transform f of x to negative f of x, the function will be reflected across the x-axis. What does that mean? What does that mean? This is basically the reflection look like this. The reflection look like this. So let me tell you, the ideal situation is like this. I'm sorry for my bad handwriting. The ideal situation is like this. This is the y-axis, this is the x-axis, and this is our ideal graph. The graph is called y equals x squared. And this graph is the graph of y equals negative x squared. Y equals negative x squared. It is called reflection. It is called reflection. Whenever you are just looking at the mirror, for an example, if you are looking at the mirror, this is the mirror, this is the mirror. You will get a reflection here too. You will get a reflection here too. You will get a reflection here too. Okay, and this is the axis of the reflection. This is the axis of the reflection. So if you wanna, if you wanna keep a mirror in this direction, then you will get a parabola like this. The reflection of this parabola, the reflection of this parabola, the reflection of this parabola, the reflection of this parabola is in the blue color, and the blue color parabola and the blue colored parabola's reflection is in the red color. These two are reflected. These two are reflection. You got it?
Yeah.
Okay. I hope so. I
Yeah.
hope so.
No, I noticed. Yeah.
Okay. Okay, all right. Okay, all right. So we have some 5 practice problems. So if y equals 3x cubed, how will the graph of y equals 3x cubed minus 5 compare? Because I've told you in the first line, that is, what thing will happen by doing what? What thing will happen by doing what? We are just subtracting. And subtracting in this case, because this is our ideal case. I told you the benchmark, right? I told you the
Yeah.
ideal case. I told you the ideal case. The ideal case and the comparing case. The ideal case and the comparing case. This is our ideal case. This is our ideal case. And we are interested to know about the compare. We are just interested to what thing will happen by doing what. What will happen if I'm just gonna subtract 5 from this equation? What thing will happen? It is gonna shift in the upward direction. It is gonna shift in the maybe in the upward direction. I'm sorry, in the downwards direction. I'm sorry, in the downwards direction. The graph will shift in the downwards direction.
Yeah.
And if y equals 4x squared, how will the graph of y equals 4x plus 2 whole squared compare? The graph will shift in the left direction.
Yeah.
So in the left direction, yes, in the left direction. If y equals negative 2x squared, how the graph? This is basically the reflection. This is basically the reflection.
Yeah.
Reflection against the x-axis. Reflection as taking the x-axis. If y equals 6x squared negative 5, how will the graph of y equals 6x minus h whole squared minus 8 compare? First of all, there will be a shifting. There will be a shifting in the left or the right direction. In the left or the right direction, and then there will be a shifting, and there will be a shifting in the downwards direction. How? How? Because in this situation, we are seeing as 6x squared. We are seeing y equals 6x squared negative 5. And we are just taking x minus 1 whole squared. In this case, we are just putting x minus 1 in the position of x, and we are putting -8. We are putting -8. We are putting -8 in the case of -5. So what thing will happen?
You
There will be
distribute the
uh, you cannot just distribute. You cannot just distribute because you just need to understand. You just need to think with your imagination. Because first of all, you just need to do some shifting in the leftward direction or the rightward direction. This
yeah
is basically the shifting in the rightward direction. First, you just need to shift it right. First, you just need to shift it in the rightward direction, and then you just need to shift it in the downward direction.
yeah.
I
Oh,
think
okay.
first of all, you just need to shift in the rightward direction because this is gonna tell you whether you are shifting in the rightward direction or the leftward direction.
Yeah,
And then this is telling you how whether you just need to shift it in the upward direction or the downward direction. You got
yeah,
it?
yeah,
This is the situation. First, you just need to go to the right direction, and then you just need to go to the downward direction. If y equals 2x minus 4 whole to the power 5, power raised to the power 5 plus 5, all the graphs of y equals 2x plus 1 raised to the power 5 -5, compare how this thing will look like. Shifting in the leftward direction, and then shifting it to the downward direction. Shifting it to the shifting it to the leftward direction, and then shifting it to the downward direction.
yeah.
How are we understanding that we are just shifting it first in the leftward direction? How? How?
Left because it's positive one.
Yes, the
Or
probably the one plus one, the plus one,
yeah,
and the -5. The -5 is telling you that you are just gonna take it in the downward direction, right?
yeah,
Okay, all right. I hope you would understand. It will become more clear. It will become more clear.
yeah,
It will become clearer if you're practicing. If you're practicing more, then it will become clearer. So visualizing polynomial graphs. So I'm just suggesting you to go through this point because this point can really help you to find out or to know what thing will cause what as the same just in our previous mathematical problems what we have discussed just a minute ago. So these are some basic rules. These are some basic rules about a polynomial. These are the basic rules for a polynomial to predict or to know some basic parameters. For an example, the greatest possible number of turns changes in y direction of this function will be at most n minus 1. The greatest possible number of turns changes in y direction of this function will be at most n minus 1. So consider a polynomial. Consider a polynomial. I hope you understand what is the polynomial. And the greatest possible number of turns, the changes in the y direction for that polynomial, for that particular polynomial would be n minus 1. And ax to the power n is the highest power term. Highest power term is that, excuse me, n is the highest degree, highest exponent. The highest exponent is called the degree. The highest exponent is called the degree. The degree of the polynomial is n. The degree of the polynomial equal to n. And the term which is consisted of the highest exponent is called the highest power term. This is basically the highest power term, ax to the power n. And if you don't know the highest power term, and then you won't be able to solve out some problems, because these are the rules. These are the rules. If the constant a is positive, the function will ultimately point upward as the x values increase. If the constant a is negative, the function will ultimately point downwards as the x value increase. If the exponent n is given, the ends of the function go the same direction. If the function n is odd, the ends of the function go in the different direction. These are some basic rules, nothing else. These are some basic rules, and you just need to answer the questions as they are asking you, and there's nothing complicated. The rules are already given. The rules are already given, and you just need to go through these problems. Just for an example, how many times will the polynomial turn with respect to its y value? Apply this rule. Apply this rule. The greatest possible number of turns changes in y direction of this function will be at most n minus 1. That is equals to n minus 1. 3 minus 1 equals 2. Will the function ultimately point upwards or downwards direction? If the constant a is positive, the function will ultimately point upward as the x values increase. If the constant a is positive, a is basically the coefficient of the highest exponent term, highest power term or highest exponent term or degree term or whatever you are interested to tell it. So if the constant a is positive, the function will ultimately point upwards as the x values increase. If the constant a is negative, the function will ultimately point downwards as the x values increase. I think you really don't have any kind of problem with this type of problems, right?
No.
Just a simple thing. Simple thing. They're having they're having two terms because the greatest number exponential value is x cube, and they will turn in two different points. They will turn in two different points. They are taking turn in this point and this point. And you can also do it by using calculus. Basically. You can also do it by using calculus. You can also do it by using calculus, because if you have the concept of calculus, then you can do it. But I'm not assuming that you have the concepts of calculus. But if you have the concepts of calculus, then you can automatically understand why this is happening. Because in calculus, it's called the inflection point. Inflection point, the point of inflection. It is changing. It is just changing just like momentarily. Calculus is amazing. I'm not going to talk about these problems in this situation because I'm not dealing calculus. So same problem. Example number 2. Consider the polynomial y equals negative x to the power 4 plus 5x cubed plus 5 negative 5x squared negative 5x plus 6. How many times will the polynomial turn with respect to its y values? Will the function ultimately point upwards or downwards? Will the ends of the function go in the same or different direction? We just need to go through this rule. And if you really want to understand why these things are happening like this, then we need to talk more about that. We need to talk more about that, but at this situation, I don't think this is the exact time to deal with this type of topic. We are not really interested that much to talk about why these things are happening like this, why how the rules are coming through, how the rules are basically invented from. Then we just need a separate exact uh, uh, very focused class on mathematics, higher mathematics. That is basically calculus. So then you will understand why these things are happening like this and how the rules are coming from.
Okay.
You got it?
Yeah.
But primarily at this situation, that is not expecting you that you understand every possible description, every possible meaning of the rules. They're just trying to let you understand, or they're just interested to judge you whether you understand what thing will happen by doing what. What thing will happen by doing what? Because in some cases, whenever we are just trying to understand programming, for example, Python programming or C++ programming, we really don't understand how it's doing, or for an example, how a number, for an example, decimal number 2.3, for an example, a decimal number 2.3, how it is being processed. because computer doesn't understand anything but 1. Computer doesn't understand anything but 0 and 1. But when a student is writing some codes, writing some program over the screen, he really doesn't know everything about the program, how it is being compiled, how it is being transferred from one language, from a low level language to assembly language, or from low level language to opcode, which is basically nothing but 0 and 1, and how the hardware is processing. But the authors of the C++ program, they know everything about it. But primarily as a student, the judge, they're not expecting you to know all of this. So like this, you are not expected to know how the rules are coming, how the rules are coming through, where it is coming from. At least you just need to understand how to use these tools. And after a certain time, whenever you are just going through your advanced classes, you would automatically understand, wow, how these things are coming. Basically, if you're just going to differentiate, if you're just going to differentiate this basically this polynomial, then you can automatically find out what how many times this polynomial will change its direction, because that is one of the concepts of inflection point. We have inflection point, we have critical point. Inflection point and critical point are not the same. We have some we have some concept that is called we have some concept that is called that is basically called uh, some different type of function. I forgot the name, but uh, the best book for studying calculus, that is Howard Anton. Uh, he is the best book, and he got the best book basically. I read it. So if you have some if you have some inclination to that, then you can just search for it. But at this moment, you just need to go through these rules, and you would automatically understand. And you just need to practice problems. You just need to practice some problems. I will help you. I will help you to solve the problems. So go through this practice problem. I think this is the most easiest problem. The easiest problems what we have just talked today in this whole lecture. In this whole lecture, I think these are the easiest problems, because these are nothing but just plugging some values. So set math strategy, integrate your knowledge about zeros, parabolas, and polynomial graphing to solve problems. Example 1, in the quadratic equation above, n is a constant. For what value of n will the function intersect the x-axis? Only once. Only once. Example 1, in the quadratic equation above, n is a constant. N is a constant. For what value of n? For what value of n will the function intersect the x-axis? Only one. It means that you just need to find the value of n. You just need to find the value of n as the function, or as the graph is gonna intersect the x-axis just only one. It means that the situation can look like this. Situation can look like this, or the situation can look like. I think this is probably the only situation, because if you're just gonna write it like this, then this parabola is gonna intersect the x-axis in 2 points.
Yeah.
So at this situation, this is gonna intersect the x-axis just in just only one point, only one coordinate. Maybe it has some imaginary point, imaginary solution, and a real solution. Maybe it has a real solution and an imaginary solution, but in the real case, in the real solution, it has to be only intersect the x-axis for only one. This is the problem that we are at. I'm gonna talk about the solution later, but can you please just at least think how to do it?
Sorry?
Can you please just think at least? Can you please just tell me what would be the possible way to solve this problem? At least just give me a hint. You don't need to tell me the solution. You just don't need to tell me the detailed solution. Just give me a hint. Just give me a clue.
Um, put it in the vertex formula maybe?
Mm, vertex, putting the vertex, mm, you can also do that maybe. You can just equate the
Find
you can just
yeah,
equate the x equals negative v by 2a,
yeah,
x equals negative
yeah,
v by 2a equals to 0. So if you want to do that, then maybe that could be a possible way, but actually I really don't know. But let's see on what they're solving this problem. This equation does
yeah,
not ask us to do something straightforward like identifying the zeros or the part. We need to find out what value of the constant n will make the function have only one point of intersection with the x-axis. To have only one point of intersection with the x-axis, the function should have only one zero. If we could factor the equation and it would have only one zero in factored form, that would tell us the constant would need to be. Notice that 25 is a perfect square. The square root of it is 5. So if we were to write the equation in factored form, it would look like this. OMG, they're just making it too much complicated. They're just telling you basically what I've just told you. They've just told you the same exact thing that is I've just told you. It just needs to be cut in one single point, just like this. Intersect in only one point. You got it? Just like this.
yeah,
Maybe just like this. I'm telling you
yeah,
maybe because it is not allowed to cut the x-axis, intersect the x-axis into multiple points. Just only one single. And how to find that? That is basically it must have to just the similar solution. The similar solution mean that you cannot get the solution. Two different identical solution mean that two different identical solution mean that you are not allowed to get. For an example, if you solve this equation, you are gonna get the solution as 5 and 5, right? 5 and 5
yeah,
are the same solution, the same number, the same number. They have two different solutions, but basically the two different solutions are the same. They have the two different solutions, but the two different solutions are the same. 5 and 5 are the same number. So potentially that doesn't hold any kind of value. So you just need to make the equation loop, or you just need to make the equation in that way, so that the equation will give you only one solution, only one solution, identical solution, and that is possibly the only possible way that you can just do you can just you can just you can just make the perfect square, make the perfect square, and then solve it. You got it or not?
yes. I know I did FOIL before.
Okay, all right. Okay, that's very nice, amazing. Okay, so this is example number 2. This is telling us the graph above is represented by which of the following equation. You just need to think about, for an example, this is turning. This is changes its direction two times. This changes its direction two times, and then um, it is having the solution. It has the solution. It has the solution. For an example, this is a point. This is a point of intersection. This is a point of intersection. This is the point of intersection, right? This is the point of intersection. This is the point of intersection, and this is the point of intersection. And the point of intersection is the solution of the given polynomial.
Yes,
And so to do that, x equals 0, x equals 1, and x equals -2, right? X
yeah,
equals 0, x equals 0, x equals 1, x equals -2.
yeah,
Simple. X minus 1, x plus 2. Y equals, this is the equation.